Good morning. Happy Tuesday. It is Tuesday, April 21st, and today I'm going to be giving you a little extra guidance on the Section 7.1 Solving Systems of Equations by Graphing. I looked at some of the work you turned in last week, and I'm seeing some careless errors, so I want to kind of clear those up. Yesterday was a Zoom chat at noon, and we had to do Alex yesterday, 30 minutes, and they've decreased the requirement on the lessons to 3. Today, a 7.1 practice is opened up for you on Edge Elastic, but really watch this video before you do that. Well, I guess if you're already watching this video, it might already be too late, but I'm going to give you some serious help. Definitely make sure you watch this video before you start that quiz. The quiz won't open until Thursday morning, okay? And I know you're going to be disappointed about this. We've been told not to give any work for the next week because paper packet kids are a week behind or something. So, yeah, I know some of you really look forward to doing your math work. I know I do. But maybe I can sneak you some on the side and we won't tell anyone. Do that. So I do have some Pinterest here today. I forgot my assignment at home, my online teacher. No, you're at home. That friend that makes you laugh when you're trying to be angry at them. My chihuahua makes that face. And gym instructors, you should be doing your at-home workouts. All of us. You'll see he's eating a Chips Ahoy cookie there. Are you guys keeping up with your gym lessons? All right, well, let's get on it. Some of you are making careless mistakes just by not knowing the vocabulary. And I have to think if you were really watching the videos, you would get those right. When we're talking about these 3 terms, consistent and independent, and inconsistent. Consistent means that the lines touch at one or more points. It means they're going to run into each other or they are each other, okay? So consistent is anything except parallel, okay? Consistent and independent would be this first example. These 2 lines are independent. They're doing their own thing, but they do touch at one point, which makes them consistent. Now over here, this is a graph of 2 lines, but the 2 lines are exactly the same line. So this one is consistent and dependent. They depend on each other. Where the one goes, the other one's going. Okay? Inconsistent means they will never touch. There is no solution. You can never find a point that will satisfy both. Those are your parallel lines. Okay? So terminology. Don't lose points for careless terminology. Now, when I ask you how many solutions a system has, and I give you the equations in slope-intercept form, all 3 of these examples are in slope-intercept form. The multiple choice responses are always 1, none, or infinite. All right? So let's think about this logically for a minute. In this first example, you'll notice that these 2 lines have the exact same slope, which means one of 2 things. They either are the same line or they're parallel to each other. If 2 lines have the exact same slope, they're traveling at exactly the same rate of change. So what you look at then is the y-intercepts. These y-intercepts are different, which means these 2 lines are parallel to each other, okay? If the slope is the same and the y-intercept is different, then they're parallel, all right? This system has no solutions. Okay? This next example, the slopes are the same and the y-intercepts are also the same. In fact, everything's the same. This line and this line are the same line, and that has infinite solutions. Every point that satisfies this equation also satisfies this one. Now, anytime you see 2 equations that don't have the same slope, that's one solution. Somewhere, somehow, they're going to run into each other because they don't have the same slope. Now, what if I ask you how many solutions and I don't give you slope-intercept form? The only way to solve this, well, one way you could solve it is you could go ahead and put them in slope-intercept form. Figure out, are they the same or are they not? So let me go to pen here. All right, if I was going to put these two back in slope-intercept form, my first step would be to subtract 3 from both sides. I want to get y by itself on the left. That gives me negative 3y equals negative 9x minus 3. I'm going for that y equals mx plus b format. Divide everything by negative 3, negative 3, negative 3, negative 3, and we get y is equal to positive 3x plus 1. Okay. Now the second equation, we're going to subtract 2 from both sides to get y by itself on the left-hand side. That gives me negative 2y equals negative 6x minus 2. And then I divide everything by negative 2, negative 2, negative 2, and I get y equals 3x plus 1. Deja vu. Where have I heard that before? Oh, wait. The first equation is also y equals 3x plus 1. So this system has infinite solutions because those two lines are the same line, right? Now, let's look at these other two. This one and this one. Try to put some space between them. There we go. Okay. The one on the left, oops. First thing I would do is get this y over to the other side by subtracting y from both sides. It gives me negative y equals, and I'm going to fix the order of the terms over here. X should be first, and the constant should be last. The only problem I have right now is y can't be negative. So I will multiply every term times negative 1, which changes the sign but not the value. So it gives me 4x minus 4. Okay, so that's the slope-intercept form of the first one. Over here, I think I'm just going to flip-flop these sides for starters. Negative 2y equals, and fix the order, negative x minus 6. Divide everything by negative 2. And that gives me y equals positive 1/2 x plus 3. All right. These two lines have different slopes. Somewhere, somehow, they're going to run into each other. Okay. So this will have one solution. Okay. I would have done a third one, but this video is going to be long enough as it is. Okay. So that's what you would do if they're not in slope-intercept form. Next, there is something else you could have done. If you were trying to find the solution, you could use Desmos. And Desmos is the graphing calculator that is available to you through Reveal, also downloadable as an app on your phone, and you can access it through any computer or tablet. Okay, you just go to desmos.com, select graphing calculator, and I downloaded the app to my phone and it works great. All right, so if I give you a system of equations and I ask you to find the solution, which the last 4 problems of your assignments today will be like that. Okay, I give you 2 equations and say, what is the solution? What are the coordinate points? What are the coordinates of the point that solves both equations? Well, without fail, you should go to Desmos, type these 2 equations in. I mean, if you want to put them in slope-intercept form and graph them the long way, go for it. But probably you don't have graphing paper at home, and I'm a little lazy. I didn't want to have to do all that work. So I say we hop over to Desmos and check it out. Hang on just a second. I'll get Desmos. All right. So here we are in Desmos. The first thing you want to do is to go ahead and type in the equations. I've written them down here. We have y equals x plus 1 for the first equation. And the second equation was y equals 5x minus 3. See how easy this was? Move your little cursor over here. There's your solution. 1, 2 is your solution. And when you type that into EdgeElastic, no spaces. Just type the parenthesis, 1, comma, 2, end parenthesis. Okay. Don't want to miss the problem because of crazy formatting thing. All right. So those were both in slope-intercept form, fairly straightforward. The second two that I had posted on the board were not in slope-intercept form. Let's check these out. We have -6 plus x equals -3y. And Desmos can totally graph those, even though they're not in slope-intercept form. Desmos has got this figured out. You don't have to do the work. The second equation was even grosser. Is grosser a word? I don't know. Grosser might not be a word. 9 plus 3y minus 4x. That is a hideous abomination of a math problem. But look at that. Desmos cranked it out for you. Move your cursor over here and boom, the solution to that system of equations is 3.1. Okay. Now, a lot of kids have been saying they watch the videos to get the extra credit points, but the number of kids saying they watch the videos is not matching up with the number of views. So here's what I'm going to tell you. I want you to, instead of saying watched, I want you to type the word Desmos. And if you type the word Desmos, I'll know you really did watch, and you'll get double extra credit. All right? So when you're done watching this video, comment Desmos. You don't even have to spell it right. I'll know you did it. All right? So you guys have a great day. I'll see you on Wednesday. Enjoy some tacos. It's Taco Tuesday. Adios.